The Linux kernel's network packet processing subsystem is called Netfilter, and Iptables is the command used to configure it. And boy, this tool is a Swiss Army knife. It's more like a katana with a hilt of a mace that is dipped in poison, because you can shoot yourself in the foot with it. It's really powerful. How about we jump into it, guys? In this video, I'll demonstrate Iptables and show you a practical example how to do port forwarding, IP forwarding, and even load balancing, hopefully in upcoming videos. This is just part 1. Let's just jump into it. These are the 4 key components of Iptables that you really need to understand. The first thing is tables, and there are really just 3 tables, right? There are the chains that you can add rules to, and third, there's matches. How do you match as packets coming into your server? How do you match it? Hey, this is, if the protocol is TCP and the IP is this, and the port is this, and the ICMP header is this, then do that, right? And then finally, the target, which is the extension to do the actual work. Whether, hey, I want to drop the packet. Hey, I want to forward the packet to a different destination. Hey, I want to redirect it to somewhere else. This is where the action is. So the table, the chain, where things happen, right? Whether it's before routing, after routing, as the packet leaves the process, as the packet comes into the process, and the matches, like how do you match the packets, and then finally the target, what do you want to do with it. Let's take an example. In this video, I'm gonna only explain the NAT table, right? Because that's where I have use cases for. The rest of stuff I'm gonna leave it for other, as I develop more use cases and actual real life scenarios, I'll add them. But I always find it confusing to explain something without a use case. It's like, okay, why does it exist, right? You always get confused. So the NAT table is the first table that I'm going to explore. Iptables NAT table. And here's the chain map for the NAT table. So as a packet enters from a network interface, whether this is a Wi-Fi, this is Ethernet, comes in, it goes to chain number 1. Always goes to a chain called pre-routing chain, right? And you can add as many rules as you want. And the next possible path, it could be after pre-routing, it could immediately go to the process if there is a process matching the port that is the destination port. If there is no port listening on port, I don't know, whatever, 777, then the kernel will not map anything to the process, right? It will just, you'll get a reset, essentially, a TCP reset. The other path is, hey, what if you actually change the path? Here, please change the target, the destination from this IP, which is moi, to someone completely else, somewhere else. If you do that, then it will go to the post routing, because you're essentially changing the route, right? You're essentially kicking it out of your kernel, out of either the same network interface or some other network interface. So that's one path. Another path goes to the process, and another path here is when a packet leaves the process, like you're sending a GET request in HTTP or POST request, it goes to the output chain, so you can do stuff of it. And after it goes to the output chain, it can go to the post routing, right? If you're leaving, like you're sending a packet to some IP address that is not you, right? Obviously, it needs to leave your network to go to the network, right? So it goes to the post routing and go there, right? Another path is, what if you send yourself, send a packet to localhost, which is a loop back, right? So in this case, you literally see it is actually a loop back, right? You go to the output and then just loops back to go to the actual process that is listening. That's called a loop back. So if you send a packet to 127.0.0.1, another port that is listening on your machine, it goes this way, right? So that now when I explain that table, how about we essentially give an example? The first popular example that I always run into, right, is I am running Node.js or Python or any process that is listening on some port. However, I don't want to give that stinking application, that shady application, root privilege so it listens on port 80. Yet I want to connect to the application through port 80, but I don't want it to I don't want it to listen to port 80 because port 80 requires beautiful root permissions to listen. Anything below 1024 require root, and you don't want to give shady Node.js root permission because this is not just a Swiss Army knife. This is more like a Gatling gun, essentially, Node.js. So do not give it root permission, please. Okay. So now I have a machine here, 10002, and it's listening. There is Node.js running. There's a web server running, 8080, right? And what I want to do is I want to communicate through port 80. I want to send a GET request. I want to do a curl. I want to go through the browser and visit port 80 on this machine. Guess what? There is nothing listening on port 80 here, right? But no, Iptables magic. Everything goes to the kernel. Remember, every single packet that you send to your machine goes to the kernel before you go to user space, before it goes to you, essentially, as the application. So now we will get a packet that is destined to me. Well, that's me, 10002, all right. But I don't have anything port 80. What we're gonna do is we're gonna map. We're gonna do a redirect. It's in the same machine. I just want you to change the port. Leave the IP address as it is. Just change the port, please. Just change the port from 80 to 8080. So that's a rule that you applied on the pre-routing, right? To change the rule so you can go to 8080. In this case, that will immediately go, and then the Node.js will get the packet, and then the rest is history. We talked about it many times in this channel. So here's how you do it in the IP table. So you do a command Iptables. Forget about the backslash here. This is just to add a new line. But -- table or -t, I like to use the full word because it's just more readable to me, at least. You can use the short word, which is -t, but I always like forget, is it small letter T or capital letter T? It's just confusing me. So I like to use everything lowercase and full word. I'm manipulating the NAT table, the network address translation. And I talked about NAT, guys. I forgot to mention that. You probably need to understand NAT before jumping into this video. This is a little bit in the intermediate thing here. So check out the video right here. So we're going to work on the NAT table. We're going to manipulate that thing. I'm going to append a rule to the pre-routing chain. That's what I'm going to do. What does it do? Well, I'm going to match anything on the TCP. Anything TCP stack, anything packet TCP, match it. Okay, got it. Yeah, HTTP is TCP. Well, unless it's quick, that's a different scenario. So be careful if you're routing quick request. That's a different thing, right? Then -- port. If the destination port is 80, match it. Got it. Yeah, I'm going to port 80. -- jump. That's the most important command here. I want to jump to this target. That's the target we explained, right? And the target name here is called redirect, and it's a built-in target. You can, by the way, build extensions, your own custom targets to do all this magic, right? I think Docker already have its own chains. If you install Docker, you'll see all these garbage chains and targets all left and right. So as you jump into this target, the rest of the parameters depend on the target. So -- 2, for example, only is applicable to redirect. If you use it with another target, like DNAT, you're going to get an error, obviously. So I want you to map to 8080. Very simple, right? And here's what happened when you actually do it, right? And then once we do this, I'm going to jump into an example, show you how this thing works. Redirect port 80 to 8080. What happens here is that we received a beautiful packet from this IP address 192.168.1.2 or 1234 destination from the source port 1234 to destination port 80 to destination IP address 10002. Obviously, the moment the packet arrives, the first thing it goes through is the pre-routing. So the pre-routing chain is applied. What does the pre-routing say? We said, hey, redirect this 80 to 8080. So we just changed it. We changed that port, which is beautiful. We changed it to 8080, right? As we go here, it leaves. So, okay, 10002 and 8080. Do I have a process running that has listening on port 8080? Yes, this is the Node.js process PID1, right? I should have added the logo here, Node.js. Okay, this is much better. All right, so we're going directly to the Node.js app. Beautiful. And now when the process finishes, it will reply with an acknowledgement. Obviously, it's going to reply back to this, right? And as it leaves, it's gonna reply back, and the packet source will be 8080. But Iptables is smart and knows, oh, I actually changed 8080 to 80. It keeps track of this stuff. This stuff is not easy, guys. Building networking and Linux kernel is not easy. There's so much stuff going on there, right? So if you actually send back the packet from Node.js all the way to the network as source 8080, that thing on the other end, the client, whoever sent this, is going to say, what the hell is this? I didn't send something from to 8080. I sent something to port 80. It's going to drop the packet. So the routing, in this case, I didn't show it, but it's going to go through essentially the output. Essentially, it's going to go through the output and then post routing, but there are no chains essentially there in this case. So it's going to just go immediately. There are no rules. But it will keep track of this and change it, right? Change it back to 80 so that the public know what it expect. Got it? All right. How about we do an example, guys? All right, guys. Here I am on my Pi, okay? And for simplicity, I'm going to just show you that if I do curl on http rpi.local, which is my machine name here, on port 8080, you can see that I have a web server running on port 8080. But if I do on 80, I get an error because there is nothing. There is no process running on port 80. That's why this error makes sense. What I want to do is, I want, when someone made a request to port 80 on this Pi, I want to immediately redirect it to 8080. So what do we do this? We're going to do sudo iptables -- table. I'm going to work on the NAT table. Let's just do new line so we can, it's going to be more readable for you guys. All right, so the next thing we're going to do is we're going to append to the pre-routing chain, right? I'm filtering, I'm matching on the protocol that is called TCP. This is optional, by the way, guys. If you don't add this, then any IP packet will be filtered, right? Regardless of its content, whether it's TCP or UDP or Quick. Maybe that's better for you. You don't have to add it if you want to. Then I want to, anything that matches the destination port that is called 80. If anything is coming to you, my friend, on port 80, right? That's another thing. Go ahead and jump to the target that's called redirect. What are we gonna do with the redirect? I want you to change the port --2, right? That's why it's just called 2, because it has to be a port. You cannot change anything else. The redirect only redirects port. That's why the parameter is called 2. Okay, and then what do we want to do? Please move it to 8080, just like that. Done. So now, all right, so let's go ahead and open a new tab, and then we're gonna do curl http rpi from another machine. Now I'm going to another machine just to test this stuff. If I do local, you can see rpi.local, and now I'm getting that, right? If I do 8080, that also works because that's the original thing, right? But we see that this works. You don't believe me? Open a browser. .local, enter, and you can see that, hello world, I'm running on 8080, but you're accessing me through port 80. Magic. All right, so now this is the redirect, guys. All right, let's go back to the slide. Let's explain the second part, which is IP forwarding to a completely different machine. How about we do that? All right, guys. So now we explained how to redirect ports into the same machine. But if you want to build a firewall or a reverse proxy or a load balancer, you gotta forward those packets to another machine, right? This is where it gets really complicated, and you really understand. You need to understand what's going on. So this diagram that I wrote here is gonna explain this, right? Sorry, I didn't do slides because I'm on Canva, but I'm gonna explain this to you. Don't worry about it. So here's the original client running on 192.168.1.2. And it's sending a packet to port 80 to this destination 10.0.0.2. Okay, and guess what? There is nothing running here on this machine. Nothing. There is no process. There is nothing. Okay, the actual process that is running is right here, and it's listening on port 80. And what I want to do is I want to forward the packets all the way there so that they can come back eventually to me. So what I'm going to do is I'm going to send a packet, hey, get request, whatever, 10.0.0.2 to port 80 from 1234 random port from moi. So now what this machine will do is going to forward that packet to another machine. How does it do that? It does something called the destination NAT. And NAT, if you don't know, guys, it's the network address translation. I want to translate the address, and here's how you read it. I want to translate the address from this IP to this IP, or from this port to this port. It can change ports, it can change IP. So this is a more general case than the redirect. The redirect only changes the port internally to the same machine. This can change the port and the IP address. So you can use this to redirect as well. So now what I want to change is, technically, I'm not going to change the port. You can if you want to, but the port is the same. So port 80 here. I want to only change the destination IP address. So what I'm going to do here is anything that is coming to me, 10.0.0.2, which is me, translate it to 192.168.123. Obviously, there are more rules and matches, right? Only if, no, don't just translate any packet, because I might SSH into that machine. I don't want you to go there, right? Only if it matches port 80. If you're going to port 80 and you're going to moi 10.0.0.2, then translate from to. So you, as the administrator who are playing with IP tables, you only have access to those puppies. You can change what to translate to. That's why I added this. Read as translate from to. From to. So you can change the destination IP and you can change the destination port, okay, as you go through. So that's called the destination NAT. However, now we changed it, right? All good. However, we changed that packet. It comes here to this machine, 192.168.112. That's the source. It's coming from all the way here. The source port, right? 1, 2, 3, 4. We just didn't change it. The source port, the source IP, we didn't change it. We just changed the destination. The destination port didn't change it. The destination IP address, 192.168.113, which is the machine. Send it over. Got it. I'm processing it. Now I want to reply to you with an acknowledgement or the actual reply. Guess what? Whom should I reply to? I only have this IP. Okay, 192.168.112. Okay, sure thing. I'm going to reply to this guy. Notice it didn't reply back to this machine because you didn't tell me to reply to that machine. You just changed the destination. So it's going to reply who? To this guy. And guess what? The guy says, I don't know you, right? So it's like, hey, where is this packet coming from? There, it's going to drop it. And when that packet drops, immediately you're going to get an error. He says, or you're going to get a retry, and then you're not going to see anything. That's why source natting is very, very critical for this. So we need another table, another one, DJ Khaled. So the other table is called the source NAT. We're going to play with the source NAT as well. So there are two tables. Technically, it's one with a wide column, but I just make it two tables so it's easy. Right? So I want to change the port for the destination, but I also want to change the source, the source IP. So you 13 reply to moi instead of that, so that I can go and do the magic remapping and everything, right? So what we're gonna do here is translate from source IP 192.168.112, which is this guy, the port, I'm not going to touch it, to source IP 10.0.0.2. So translate to source IP 10.0.0.2. That's why it gets very confusing. When I first read it, I was like, okay, how is this source and to? It's either source, it's a contradictory things. Like the to side is the to side, right? And then you're saying the source. That's why you have to read it this way to understand it. Again, always do this. Translate from source IP 192 to source IP this. It's the translation that is attached to the semantics of from and to. The source IP and source port has nothing to do with it. Okay, now what happens? Let's go through the chain. Let's go to the chain. And I'm going to do two chains here because you saw that, right? Well, first of all, there is a chain which is called pre-routing. As the packet arrives to me, change. And then as the packet is leaving, change. So this will be the source natting. This will be the destination natting. So as the packet arrive, to this machine. This machine is 10002. Got it? And we're arriving on port 80 from 1234. This is the source port. This is our source IP address. The first thing, pre-routing. What do? Change the destination NAT IP address to 192.168.1.3. We explained that. Change. What do we do next? We'll say, okay, where's 19? The kernel says, where the hell is 192.168.1.3? Well, it's definitely not this machine, so I need to send it out to the network. So it's okay, so it definitely is not going anywhere next to my stuff, right? So it's going all the way to post routing, and then as it leaves post routing, it's like, by the way, while you're leaving, change your source, translate your source IP from 192.168.1.2 to the source IP 10002, which is moi, which is I. This is my machine. This is the blue machine that we talked about. And then go your merry way. Now, I'm going to explain also the other way. When you send that machine to 1.3, this is now machine 192.168.1.3. It just got this beautiful packet that we just forwarded, right? And what does it do in this case? This is a simpler chain. And there's no, technically, we didn't do any rules here. So it will say, hey, 192.168, that's me. All right. Okay. Pre-routing, do you have any chains? Nope, I don't have any chains. You're going to port 80? Yeah, I do have a listening port in here. Port 80, listening. Go ahead and poof, it will just shoot it right there. The final port here that I want to make, that I spent hours trying to figure it out. If you do not enable IP forwarding on your Linux box, this will not work. You have to enable that bit. It depends whether it's a Raspberry Pi, whether it's Ubuntu, everything is different. Okay, find out how to enable IP forwarding. I'm going to show you how on my Raspberry Pi, but I got to link out how to do that. You have to do this. Do not make my mistake. Otherwise, you're going to spend hours debugging. It's like, why is the other machine not getting the packets? Let's go jump to the example. So here's what I have here. On this machine, 192.168.254.10 on port 8080, I have some content right here. Okay, this is it, right? And actually, let's go to a browser so it's better. Let's go to a browser. I have a site called Mark Tire Pros, where they are the pros for tires. They like tires. They're making tires. They fix tires. They repair anything related to tires. But it's running on port 8080 and it's on a different machine. What I want to do, when you go to http rpi.local on port 80, which I need to clear that, by the way, I need to clear that rule before we continue. Remind me to do that, right? I want you to go to Mark Tire Pros running there. Now it's doing this thing, right? It's doing our thing. I wanted to redirect to a completely different machine, completely different port. So we're doing two things. How do we do that? So we know this is the machine that is running. Well, this is what we're going to do. Let's go back to my Raspberry Pi and let's clear the NAT table. How do you clear the NAT table? Very simple. Sudo iptables -- table, and then you have to specify what table you'll work with. Again, I'm only barely touching the iceberg here. We didn't touch anything. This is the NAT table, and we barely scratched the surface, my friends. -- table NAT, and then we're going to do -- flush. Flush that damn thing. Nothing's there. By the way, I forgot to show you how to list stuff. You do -- table NAT -- list. We'll list everything in the NAT table. Currently there is nothing. I wish I show you how to show that, but it's okay. It's okay, guys. Now you know. I'm gonna list all this command in the description below. Just jump into it. I definitely we're not gonna do the load balancing in this episode. I'm gonna do it in another video because it's gonna be like a 40-hour video in this case. Let's continue. Sudo iptables, my friends. This guy. So we're gonna do sudo iptables. What are we gonna do? We wanna work with the NAT table. Now, guys, we need to add two IP table rules. The first rule is on the pre-routing, and the second rule is on the post-routing, right? Is it called post-routing? I forgot what it's called. Post-routing. So I want you to append on the pre-routing chain when the protocol is TCP, when the destination. Now I'm really interested in the destination. Why? Because remember, if you're a firewall or a gateway, you're not necessarily always the destination, but you're transparently getting packets sent to. Does that make sense? Right? Like your router, every single packet that you send, every single site you visit goes through your router. Is it your final destination? It's almost never, but it goes through it. So it needs rules. It's like if it's really to you or not. So 192.168.254.47, if you are destined to moi, which is this Raspberry Pi, this is the IP address of the Raspberry Pi, right? Which is this is rpi.local, by the way, guys, just if you don't know. And D port, if the port is 80, if you're going to port 80, let's go ahead and jump. What target do we jump to? DNAT, the destination NAT. We're changing the destination NAT. Guess what? Not only the IP, just like the example that we showed, I'm gonna change the port because I live on the edge, babes. I live on the edge. So we're gonna change it to destination 192.168.254.10. And then boom, IT 80. That's the port. That's the machine, the other machine that is running my beautiful Mike Tire Pros, right? We're gonna make Mike Tire site public today, okay? And by the way, to destination, again, as we explained, this is a parameter that is only applicable to the DNAT target. It's not applicable to anything else. Enter. Is this enough? Absolutely not, because yeah, you can send a packet now to 192 to the Raspberry Pi on port 80. It's gonna get forward to that, but this poor guy is not gonna be able to reply because guess what? It's trying to reply back to itself in this case because whatever, and it's gonna get confused, right? So we need another one, DJ Khalid. Another one. We're gonna do NAT. I'm cheating now, I'm just looking up. Post routing. I'm gonna add a post routing as the packet now that we know the packet's gonna leave me to out the network interface, which is my Wi-Fi in this case. By the way, guys, you can do so much stuff here. You can do the --in interface. If you have like 7 interfaces, you can control which interfaces you want. But usually, if you have the IP address, that's enough. But if you do the interface, the check will then be faster, right? Because this is at the end of the day, it's all checks, right? It's searching, and you want to make the search as fast as possible for the kernel. The more parameter you give, the faster the search gets, right? Because you eliminate. It's like if you have 7, I have only one interface, which is the Wi-Fi one, right? But if you have like LAN and switches and Wi-Fi and 3 Wi-Fi, I don't know why would you do that, but if you have that, then do specify the interface by doing --in interface. Or if you're feeling kinky, just do -i. Just -iw LAN 0. Only if you're feeling kinky, right? In interface. I don't want to do that though. All right, --append. Only if it's protocol TCP. Again, might be working with quick, so be careful there. Now, if your destination as a packet is 192.168.254. Can you guess? Take 3 seconds to guess. What is my destination in this case? Yes, 10. If you're leaving and going to 10, not enough, and your destination port is 8080, then you're eligible to a source NATing here. What are we gonna do? We're gonna jump into the SNAT, babes. What are we gonna do with the SNAT? We're gonna remember this now. This is where it gets confusing, guys. My to source, right? Translate source, right? Translate from this source to this source. That's how you read it. Okay. What is what do you translate it to? Translate this source IP address to 192.168.254 to their Pi IP address, which is 47. And guys, it's all recommended that all this IP addresses are static, right? If they are dynamic, then you're screwed, man. right? You have to use masquerade and all that stuff, which I'm gonna talk about in another video. Enter. Now that we have these beautiful two rules, clear sudo iptables dash dash table nat dash not flush, don't flush me, list. So we can see that's beautiful. Look at this. It actually recognizes, oh, you're going to HTTP. Is the HTTP protocol. It knows that port 80 is HTTP, so it shows you like an aliases, and that's cute. And you can see that is going, anything that is going to this destination, raspberry.pi.home.local, that's my domain, my local domain, going to HTTP port, which is 80, to go to this destination. And the post routing, as you leave me, my friend, go and change that to the destination port HTTP alternative, which is 8080. God, that's just, come on, Iptables, come on, man. Insert the Joe Biden meme here. Come on, man. Come on, man. Don't do this. Don't do this. Okay, don't try to be smart. I hate when like we just show the port. Okay, don't oh, this is the alternative port. What the hell is that? 8080. Is it really an HTTP alternative? I don't know. I don't know anything, guys, by the way. 2 192.168.254.47. Change moi to the translate the translate from this source, which is whatever the original 10, to this source, to the 47. So I become your source. So you send me the packet. Now we explain this stuff. Let's see if this stuff works. Is Mike Tire Pro's site up and running? We go to HTTP RPI. Are you guys ready for this? And it shows this. Why? Because Chrome is dumb, because it's caching. And next refresh, let's do caching. Caching sucks. All right, now no longer caching because in incognito. What the hell? Why does it enable dictation? No, not now. Mike's site is up and running, babes. That's it. That's it for me today, guys. Whoa, wait a second. We didn't show you how to enable the IP forwarding. All right, guys. So finally, it worked for me because I had the IP forward enabled. So make sure to do that. So for the Debian Raspberry Pi, in my case, it's so you do sudo etc, I think sysctl something, sudo vim, I believe sysctl.conf. And then you go all the way and find net IP forward and uncomment this line. Just make it one, right? And if it depends, find out how your Linux distribution did it, because it's everywhere is different, but enable IP forwarding. Otherwise, this stuff doesn't work. Okay, guys, that's it for me today. I really recommend you get the book Linux Iptables. I'm going to show it in the screen here. Linux Iptables is a pocket reference. It's really good. I really enjoyed reading it. The only, I guess, criticism for that book is just, it doesn't show you examples. Just show you, hey, you can do this. You can do this. Here's a bunch of stuff, but it doesn't explain use cases for it, right? It's just like, hey, there's a bunch of stuff, and it didn't show you the IP forward, it kept me very confused for a long time, right? I tried to come up with use cases. This is real use cases that I ran into. I'm gonna make up another set of videos to kind of follow up and show you some examples, guys, different part. Let me know if you enjoyed this episode. Hit that like button, subscribe, share with your friends, and then I'm gonna see you in the next one. Let me know, what do you want to see in the next episode? Can I see you in the next one? You guys stay awesome. Go buy your